The hunt for the time-traveling particle. Tachyons are entirely theoretical. They have never been observed within experiments as real particles have. However, it is possible that what we envisage as tachyons actually exist in other objects which we have already discovered. In fact, some neutrinos are believed to have a tachyonic nature too. In 1985, it was suggested that neutrinos are actually tachyons. And in 2014, Professor Robert Ehrlich identified what he believed were 6 measurements one could use to prove the existence of tachyons as electron neutrinos. Various techniques were used to achieve this, including the observation of gravitational lensing, neutrino oscillations, double beta decay, cosmic ray spectra, and cosmic microwave background fluctuations. Ehrlich's research seems to indicate that neutrinos, like tachyons, do indeed have an imaginary mass, which would be a mass whose numerical value would be represented by the square root of a negative number. Mathematicians will tell you that a negative number cannot be squared, but physicists contend that they can. So, in your face, math narcs. But now, we've got a new problem. We must try and reconcile the existence of tachyons with our understanding of the relativistic universe. One theory which attempts this is the reinterpretation principle, which suggests that a tachyon sent backwards in time can be reinterpreted as a tachyon traveling forwards in time because of the inability of observers to distinguish between the two. Detecting a tachyon which had been sent from the future, an act which would violate causality, would result in the creation of the same tachyon and its deliverance forwards in time as a causal event. It's a little bit like getting a pair of sneakers off eBay marked as new. Without context, you have no idea whether they're new or not. They could have been worn 1,000 times by a guy with fungal nail infections, only for him to spruce them up shortly before sale. The same goes for tachyons. An observer would not be able to tell whether a tachyon had emerged from the past or future, so messages backwards in time could not be sent and causality would therefore never be compromised. An example of this scenario is described by the anti-telephone paradox, whose proposed solution lies in the fact that every observer emits a tachyon, but there is no information exchange taking place. Alternatively, it may be that tachyons do exist, but they do not interact with anything and can never be detected or observed. The problem with this model is we have no way of ever proving it, and we have no evidence for such passive objects existing within the universe. Another theory, posed by Herb Fried and Yves Gabellini, argues that tachyons may be the answers to both dark energy and dark matter. Their paper suggests that fluctuations between tachyons and anti-tachyons may have caused and be continuing to cause the inflation of the universe. High-energy tachyons, who are a perfect candidate for dark matter, would be rendered invisible due to their absorption of all the photons they emit. And if a high-energy tachyon were flung into what's known as the real vacuum, and if it were to meet an anti-tachyon of the same type, this quantum explosion of energy could seed the creation of a brand new universe. Oh look, there's a theory for the inception of the Big Bang right there. Now that is handy. James Wheeler and Joseph Spencer of Utah State University believe they have a different answer. But their solution also has some rather unsettling consequences for the nature of existence itself. Wheeler and Spencer imagine a setup similar to the light cone diagram we explored earlier. Their theory considers a universe without time, just space, where physical distance, speed, and trajectory are our only concerns. In this model, all the trajectories start at the flared base of a cone, known as the past cone, and move towards a peak where they converge. The trajectories then move out again at all different directions to form a new cone, the future cone, and this supposedly explains how all objects in the universe began moving and will eventually come to a standstill. This process results in something which roughly feels like time, but which isn't really time at all, it's merely a mirage. Tachyons cannot exist outside the cones in this model because everything takes place within the past and future cones. But since events in space-time can be accurately modeled using this timeless theory, it is deemed by the authors to offer a workable solution to how tachyons may appear to transcend time within our relativistic universe. Quite simply, space-like curves don't exist, And because tachyons, if they existed, exist in space-like curves, then tachyons don't exist either. Knowing whether or not tachyons exist could be fundamental to our understanding of the universe. If tachyons do exist, it means we can potentially affect the past and the future, whether or not our universe is deterministic. But if tachyons are not real, and the speed of light is a solid limit upon the events of the universe, perhaps we can predict what events will come to pass long after we're gone. Perhaps there is a limit as to what can happen within a certain region of the universe that's determined by the speed of light. Maybe the future is more immeasurable than we thought. And when you know the future of everything you can possibly see or do, what more is there to know?